3, 2, 1.
New York, NY. LaunchPod start now.
Fortunately, Radiator Labs does not have that problem because the inefficiency we're carving out for the building is gross, unnecessary waste. So we're making people more comfortable while getting rid of this waste that really is almost unconscionable. I can throw some numbers at you. In New York City alone, $1.2 billion worth of fuel is wasted every year to overheating. So imagine taking like $1.2 billion of any fuel you want, and burning it in the streets. That is literally what's happening, because when our buildings consume heating fuel, they combust and let it out into the air in which you breathe. You've probably seen those big black plumes of smoke come out of the building. That's a boiler. You've probably cleaned off of your windows black soot. That's from boilers. 80% of that is from boilers. It's not from cars.
Welcome to the New York LaunchPod, a podcast on new startups, businesses, and openings in the New York City area. I'm Hal Cooper-Smith, and the voice that you just heard was Dr. Marshall Cox, the founder of Radiator Labs. Radiator Labs invented the Cozy, which is a smart radiator cover to prevent overheating in rooms due to radiators, so that people don't have to open their windows in the winter, landlords don't have to overspend on heating, and all this while being able to control the temperature from a smartphone. Marshall estimates that $1.2 billion per year is spent on overheating, and he might know since he's a PhD from Columbia. In this episode, we go in depth about that ubiquitous New York City item of the radiator, and at the end we even discuss why they sometimes make that obnoxious clanking sound, so you won't want to tune out. If you're a new listener, welcome, and if you're a returning listener, thank you for coming back. I'd love to hear your opinion on this new format with an introduction. Now, let's go to the interview. Stepping onto the LaunchPod, we have Marshall Cox. He's the founder of Radiator Labs. Thank you for stepping onto the LaunchPod, Marshall.
Absolutely. Thanks for having me.
So what is Radiator Labs?
Radiator Labs is a company that essentially is trying to eliminate the overheating in older buildings. And getting some more detail, the overheating is actually indicative of an enormous amount of waste in these older buildings. Actually, it's the single largest line item of waste in U.S. buildings, steam heat, which is what heats the majority of buildings in New York City.
So you developed a product that covers radiators in older buildings.
That's right.
What are you defining as older buildings?
Older buildings are ones we define as those built essentially before World War II. And this gets kind of into the arcana of steam. So, a lot of buildings in New York City are heated by steam, and a lot of them are that old. And the reason is because before World War II, we didn't really have good water pumps or good fans. Those systems weren't really reliable. So the only good way to heat a big building was to boil water in the basement and let that steam rise through convection through the pipes and heat the spaces. The reason why we now have buildings, and these buildings are overheated, is not because steam is bad. Steam is actually great. When these buildings were first built, they were amazingly well built. They were really well balanced. And then we invented double pane insulating glass. And when we pretty much universally retrofit our windows, an apartment with 2 windows versus an apartment with 1 window, you completely change those windows, and now they need completely different amounts of energy. But they have the same radiators, the same pipes, and so now you basically have to cater to the coldest, worst apartment in the building. And when you heat that apartment up, the rest of the building gets disgustingly overheated, and the only thing you could do is open your windows.
Well, I love the concept because in New York, everyone thinks radiators. They seem like radiators are all over the place. How many buildings do have radiators in New York City?
That's a tough question, actually. It's we spend a lot of time looking through city data, the census, et cetera, and there's hundreds of thousands of buildings in New York City. We actually know that the number of radiators, more or less, and you can decipher that from how many rooms there are in apartments. There's about 10 million radiators in New York City, 10 million steam radiators. So there's a lot.
And it feels like everyone has had an experience living in an apartment with a radiator or an office or something like that.
Yeah, no, it's one of those New York City experiences. There's a lot of tourists, it's loud, sometimes it's dirty, and you live in a sweltering hellhole in the middle of winter.
Why did double pane glass mess up everything? You talk a little bit about it, but these older buildings, they get really hot in the winter. If we just replaced all the windows that were single pane with double pane, shouldn't everything just be more efficient? Why did everything get thrown out of whack?
That's a good question. The reason is that single pane glass leaks more energy than, your brick wall. When they were sizing the radiators to different rooms, it was really a question of how many windows do you have? And Double pane insulating glass is a huge advance in insulation over single pane. It's almost as insulative, and sometimes you can get crazy ones that are more insulative than your wall.
What exactly is this product? It's a cover that goes over the radiator. How would you describe it?
So the Radiator Labs Cozy is a smart radiator enclosure. And, we get this question all the time. No one understands how this works. And the very quick answer, which is engineering parlance, is we are using this cover to thermodynamically manipulate the condensation of steam within individual radiators. I can use another terrible analogy here. So if you've ever taken a camera out of an air-conditioned home into a hot outdoor area, you might have noticed that the lenses get fogged up. That's because cold surface, if there's humidity in the air, a cold surface will condense that humidity onto itself. In a steam system, a similar process happens. You're boiling water in the basement, that steam travels to cold surfaces and condenses on those cold surfaces. That's actually the majority of the energy that's transferring from rooms. It's the condensation of steam. It's not necessarily that the water's hot, it's that when steam turns into liquid, it transfers a lot of energy in that process. So when we install these covers in rooms, the way that we're controlling how much heat transfer there's in rooms is we control the air temperature inside the enclosure. So hot air rises, and our covers block that hot air from rising, and then we can reestablish it with a fan. So if you're in a room that's historically overheated, we put this cover on, our fan doesn't turn on because the room's not is perhaps overheated, and the air inside the enclosure heats up very quickly to a very high temperature, and that temperature is steam temperature. And when the air inside the enclosure is steam temperature, the steam inside that one radiator can no longer condense. And so the steam system is trying to heat that coldest apartment. And in a normal building, they're condensing steam everywhere because every radiator is cold, quote unquote, relative to steam. But when we install the Cozy throughout a building, in those hot rooms, we can basically make the radiator look very, very hot so that steam does not condense in the hot rooms. It travels to the colder room. You're not wasting steam condensing in places you don't need to. And so you more efficiently get steam to the cold places that need it.
Now, we didn't talk about this at the outset, but you're a very smart guy, a PhD in engineering. Let me see if I can translate that in layman's terms.
Please do. I would use it a lot.
I did a little bit of research about radiators. You let me know if I'm doing this correctly. But basically, a boiler will heat up water into steam and make that steam touch a radiator, which will heat up an entire room. And with your enclosure, you're able to make it essentially airtight. Before a room overheats, the steam will go to another room.
It's close.
It's close.
Yeah.
Where did I mess up?
Yeah, it is complicated. So we don't need to be airtight. All we have to do is be able to control whether air rises or it doesn't. And so the way we do that is that we have a little fan. And when the fan is off, hot air can't go anywhere, so the air heats up, and that's how we affect the condensation rate of steam. And then when the room is cold, we turn that fan on, and we kind of blow cold air over the radiator and out into the room. And that's how we basically turn that heat transfer on. So our systems are measuring room temperature and radiator temperature in real time. If the room is cold and the radiator is hot, that fan turns on, and otherwise the fan is off. There's more complexity to it than that. All these systems are connected to the internet, so we can take all that data and we optimize. We tell the building's boiler to turn on or turn off. We control that. And so we can use things like it's going to get cold in a few hours, or it's going to get really hot in a few hours. So you should probably change the amount of heat you're generating right now because the building has a huge thermal mass and it will overshoot if you don't do this. So we know way more about what the building needs than we've ever had before, and we're able to control it, basically increase the efficiency by dramatic amounts, all while giving temperature control to tenants for the first time in the history of these buildings. So that's an integral part of what we do. We give everybody an app that they can control their temperature with. I've never been able to do that in my apartment before I invented this. It's a pretty uniquely powerful thing to have that it's amazing that we don't have.
So now that the building is connected to the internet, if it's going to get colder out, for example, will you know overnight, okay, time to fire up the boiler, time to heat up the building before it gets cold so that the air goes throughout the building?
Sure, you can do that, and I would call that a second order effect. And what I mean by that is it's actually it's not a big deal that it's going to get warm or it's going to get cold the next day. It's catering more to the moment than to what's going to happen in the future, not because it's not important, but because it doesn't have a huge effect. That being said, the real thing you're driving to is what is the temperature in the building right now? And obviously our system tries to balance that out. Does somebody want a nice setback? Does somebody not want a nice setback? Basically, let's make sure that the boiler's giving enough energy that the building needs right now and then is not overheating it. There's a subtlety to how our system works that kind of gives us more control than what a building has right now, beyond just turning off condensation. And that is that every time we install a cover on a radiator, we're essentially creating an energy storage device. In a normal apartment, say yours or mine, without a cover, the room gets cold, let's say the boiler's catering just to you, and so it turns on, then your radiator gets really hot. Your room's going to heat up to whatever temperature you want, let's say a comfortable temperature, but then you have a 100 degrees Celsius smoldering mass of iron in your apartment that overheats it. And there's nothing you can do to stop that, right? If the radiator's hot, it's going to heat up your room. In our scenario with our Cozy, you heat up the radiator, the room heats to whatever temperature you want, and now you have this 100 degrees Celsius hunk of metal inside a cover which can store that energy for when your room needs it. In a normal, unmodified building, when the boiler turns off, the radiator gets cold and your room's going to get cold. And so there's this overheating, underheating, intrinsic temperature swing that you have to experience. There's nothing you can do about it. In our system, we can heat up the radiator, get your room to the right temperature, keep it there. And then when the boiler turns off, we have this energy reservoir we can draw from slowly over time to keep your apartment at the right temperature to bridge the boiler off time. And so we can actually keep not only your apartment at the temperature you set, but we can do it consistently with almost flat line accuracy.
And how can I set the temperature in my room, in my apartment, with a radiator that I've never been able to do that before? How are you able to do that?
So the default system set point is 75 degrees. Some people want it lower than that, but what we do offer is a free cell phone app that lets you control the temperature much like you would be able to control with the Nest thermostat, for example, if you're familiar with that.
And is there any leakage from the unit at all? You mentioned that it's not that important. Okay.
It's actually a part of the design. We don't want our fans on 24/7 whenever heat is needed. You can insulate the cover to whatever extent you want. We insulate it to a certain amount so that heat leaks out at a rate that's more or less necessary during a warm winter's day. And perhaps more so, we insulate it so much that temperature of the surface never exceeds a comfortable temperature. You touch a radiator, you're not going to touch it again because you're going to burn the crap out of yourself. We insulate this so the cover never exceeds a comfortable warm temperature.
How did you come up with this idea?
So you mentioned I'm an engineer. My expertise is actually in a really weird field, which is organic semiconductors. If you ever heard of an OLED TV, I was part of that research field for a very long time. But I lived in a hellhole. My apartment was just outrageously hot, and I complained incessantly. Actually, this is a good story. I lived in this apartment for 3 years and up at Columbia, and I just acquiesced to the fact that I lived in a miserable, hot apartment in the winter. I didn't really do anything about it. I complained, but I didn't do anything about it.
For 3 years, you didn't do anything.
That's right. And then so I have a twin brother who is a professional ballet dancer. He was actually pretty famous. He danced in Miami City Ballet. He was a principal there for almost 10 years. And then he quit and moved to New York to dance in a Broadway show. So he danced in the Twyla Tharp Come Fly Away show. But it was a new show, so you never know how long they're going to last. And he slept on my floor for 6 months and did not stop complaining. Just every day. It was like, why? Why is it like this? And he was next to the window, so I mean, he bore the brunt of the unfortunateness of the overheating. But essentially because it was a constant
Because
reminder.
it was hot and then the window was cold.
Exactly.
Right.
He was a very unhappy person. And for good reason. He really did. He was on an aero bed, so like it was not the most comfortable situation for him. Anyway, so based on that, his complaining, I internalized those complaints and talked to my advisor at Columbia. And he and I kind of thought through a solution, and I built it. I actually built it overnight, and it worked.
Overnight?
Yeah, it was really easy to build. There's this cool thing called an Arduino, which is like a hardware hacker tool. And if you know how to use it, and anyone can learn how to use it, they're amazingly easy to use. You can build an electronic system trivially. And so I did that, and I attached a fan to the Arduino, I attached a thermostat to the Arduino, and built a insulating cover out of, I would not advise doing this, a foil-faced bubble wrap with duct tape. And the temperature of my apartment, though my apartment reeked of duct tape, for like days, and that was horrible. The temperature was just like a dream. It was perfect. And that basically drove me to, wow, this could be something. And so I looked into it. I talked to Columbia University. And I think the real catalyzing moment was we competed in and won the MIT Clean Energy Prize in 2012. And that was a little over $200,000. And we used that to basically develop the first real system that then went on to save energy.
It's no longer made out of foil bubble wrap and duct tape. What is it made out of now?
So now it's made out of what's called galva steel. It's a steel that doesn't rust. It's metal. And we have this very large metal fab that can bend, weld, they can do electronic components, and they ship to whatever buildings we need to install.
How long does it take to install a system?
The installation is very quick. So it takes about 5 to 10 minutes on a good radiator. Of course, we always run into, you have to move stuff, you have to negotiate with the tenant, you have to make sure they're home, and it could take longer than that. But you get into an apartment with a radiator enclosure, and 5 to 10 minutes later, you'll be done.
What if there's stuff over the radiator, either pipes that are in weird places, or let's say that some of the older buildings, I'm sure you've seen this, have built-ins already.
Oh yeah, absolutely. So we do a bunch of things. Some buildings we just don't do right now. So baseboard, for example, we don't have a cover for baseboard yet, though it's in development. So we come in, we look at the radiator, we measure all of them. The survey step identifies all those issues. If there's a cover there, we typically like them to remove them because it's a cover that doesn't do anything. We have a cover that does. If they're really tied to them, if it's a beautiful built-in mahogany, amazing cover, we can install underneath it usually. We have ways to solve the problem in almost every situation.
So once you develop the prototype from duct tape and bubble wrap, what was the next iteration?
The next iteration was a fabric cover. There's a pretty robust community in New York that helps startups, matches them with producers. And so we found a bunch of people who could make fabrics, who had fabrics, and we tested them to figure out what fabrics work for this situation. And we basically used what I would say glorified oven mitt to make the first covers.
And that's what won the MIT prize?
Actually, it was before that. But the MIT prize, if anyone listening has a startup or an idea, I would urge them to compete in business plans, and particularly if it has clean energy aspects to it, the MIT Clean Energy Prize, which I think is the best business plan competition in existence. We went to that prize and presented essentially horrible data showing that nothing was working, a data set I was pretty depressed to present. But we said, this is the data we got, this is what we learned from it, and this is how we fix the problems we had. And that was a really compelling message for them. I think that's why we won. So it was before the fabric and kind of more sophisticated communication and control that we went to the MIT Clean Energy Prize.
What was wrong with the data then?
It's funny. I still remember we got I think it was one of the first media things we were talking about, or first articles actually, where I was describing some of the problems. One of the problems is we chose this really loud fan, and it was annoying, super annoying, and people were really angry about that. And I remember one of the comments to the article was like, "What is wrong with you? Of course the fan's a big problem." And it's amazing that it wasn't. I wasn't really thinking about the sound of the fan. We really don't want to annoy the crap out of people. Yeah, I mean, that was a problem. There was issues with the control of the boiler. Actually, one of the buildings, the boiler just broke on for 3 months. The boiler was on for 3 months. We're telling people that it was on. It was just not addressed. So there was all these crazy things that happened like that. But it was all worthwhile, I guess. It was not a good data set, but it helped us get to a good data set.
How many iterations of the Cozy until you got to the product that you have now?
I'd say 5 or 6. Not all the iterations are big. The first fabric version I sewed myself. I learned how to sew. I bought a sewing machine that I don't know where it is anymore. It's kind of sad. And the first fabric version was different from the second fabric version because we used a different fabric. We iterated on the system that houses the fan. We iterated on the PCB every single time, the printed circuit board that is the brain. We iterated on the data capture or the server that nowadays is a pretty sophisticated DynamoDB. It takes data in, it facilitates connections to other databases that connect to the cell phone, that connect to our dashboard, which analyzes all the information to try to extract useful information, right? Every step is not necessarily large, but significant.
What do you need to install Cozies in a building?
This kind of gets to how we sell. So today we sell to whole buildings. And that's because one of our value propositions is saving energy. And to save energy, we need to deploy this in a majority of the building. The process is now find a building owner that wants to do this. We go and survey the building. And you have to remember that every radiator is different size and shape. It's dramatic, the number of variations we see out there. And this gets to more of the steam arcana. So a lot of these radiators were built by Bob in Brooklyn in his basement for decades. And then Joe, maybe in Queens, was building his own radiators. And this is back a long time ago. So a lot of these radiators were built before standardization. There are crazy variations we've seen. We really have to go into every apartment, measure every single radiator, and then we build a cover specifically to cover that radiator. So survey happens, we build them, we come back, and we install them. That's the process.
So the whole building needs to have your product in order for it to work.
The majority, I'd say over 70%. We get emails all the time. People want to install this in their own apartment, and we can't sell them to those people yet, although we're working on it, because there's a lot of complexity. Can we trust a consumer to measure their radiator with the accuracy that's required? Because there's a lot of weird stuff that you really have to be careful of. Is the windowsill overhang the radiator? Is there a pipe that needs to be measured? How do you measure a pipe, right? So can we trust the consumer to measure it accurately? That's a question we have to answer. Can we rely on the customer to be able to install it? Probably, but it's going to require a lot of instruction, and if they do it wrong, they're going to be really upset. So we don't want to get in a situation where someone self-installs, it's not working, and they call us on the coldest day of the year when we're working to make sure all of our other buildings are working. So we'll do that at some point, but not yet.
And all the apartments need internet access?
Actually, no. So there's 2 things we hate right now. One is batteries. hate batteries. The other is relying on people to connect things to the internet with data that we need. We don't have batteries. You can't actually have batteries on the radiator because they can't survive the temperature. So we plug into the wall. That's actually a big limitation for us. We really need a wall outlet, though it's not a problem. We rarely have it be a problem. The other limitation is internet connection. What we actually use is something called a Zigbee wireless radio. And the Nest has a couple, actually more than one, which is weird. But essentially the way it works is a radiator talks to the radiator next door, which talks to the radiator next door, all the way down to the basement. And there we have this central, what we call a gateway, that brings all that data and connects to the cloud. So it uses what's called mesh networking.
You only need one internet connection to set up an entire building, and everything else is. And then is it difficult to set a boiler up to an internet connection as well?
Yes and no. The answer is really, some buildings already have it. A lot of the newer boiler controls are already internet connected. And if you're a building owner and you have a dashboard that shows you what's going on, you're connected already to your boiler. We speak to boiler controllers through the internet. We work with some of the biggest boiler controllers out there. But if you're in a building that has an old system that does not have an internet connection, you have to upgrade it to work with our system. And some compelling reasons why you should update it anyway.
And so what does all this cost?
That's a great question. So right now, we are selling more or less the covers for about $500 each. Some landlords, some building owners are okay with upfront costs. For those who aren't, there's financing available. And there's also a lease model that we're developing right now. So we're trying to cater to every kind of building owner, whether they have a large capital capability or if they don't.
And what's the savings?
The savings vary. So it's a question we get a lot. If you go on a diet and you're rail thin, you're not going to lose much weight, right? If a building is efficient already, we basically tell them, this is a value proposition that is mostly comfort. If you want to give control to your tenants, if you want to be able to see all the analytics that we provide on buildings, that's why you should buy this. Obviously, there's a lot of buildings that are inefficient. And for those buildings, the value proposition is you're going to save a ton of energy. It's more compelling. So we have a few buildings we've done so far. We've done about 12 buildings. We're about 1,500 apartments. We're doing many more this year. We had our first third-party verification report come out. And I believe you saw that. Some buildings up at Columbia University, where I invented the technology, actually. And those buildings saved actually, we have our own internal report and we have a third-party report. Our internal report says that one building saved 24%, the other saved 34%. The verified results say that both buildings actually saved 41% off their heating bill. So you have to understand the parlance that goes on here. Your heating bill is what's the energy is used for heating, and then your energy bill usually includes heating and hot water. So the third-party results say that including hot water, we saved 23 and I believe 26%, but that's including something that has nothing to do with heating. Our results say it's 24, 34% without the hot water as well.
So if someone's investing $500 per radiator, what's the time horizon until a building owner would see payback?
That's that's actually a complex question as well, and I'll try to answer it. It's energy costs, and it's how efficient the building is, and it's what fuel the building consumes. So if you're on natural gas is super cheap right now. So paybacks could be 5-10 years if you're just selling it on that one value proposition. If it's oil, it could be 3 years, it could be 5 years, it could be 8 years, again, depending on what the building's experiencing. If it's district steam is crazy expensive. It could be 3 years, it could be 1 year. It really depends, again, on how much energy we can save, what the building's like, etc.
When you talk to a landlord, a building owner, what do you say to them?
Whenever we talk to somebody, they're usually coming to us because they have a problem. One of the nice things about working in this market, at least in the context of sales, is that a building owner walks by their building and the thing they see in the winter is that all their windows open and they're like, why are they doing that? I'm paying for fuel. So this is actually another arcana about steam. It's really hard to submeter steam. So while you might pay your National Grid gas bill or your electric bill, no one can really measure how much steam you're consuming. And so your rent pays for your heat. And all that is to say that your landlord is paying for heat. They're paying the fuel bill. So they see the open windows and they go crazy. So they come to us, they ask us, what can we do? And we tell them, your building may or may not be overheated. If you have indications from your tenants that they're boiling in their rooms, that's a good indication. But let's start out by going to your building, making sure it's a good fit for technology. We use the data that's available to measure how efficient is your building? How does it compare to other buildings? And then we can come back to the building owner and say, okay, this is what we think we can do in your building. There's things that are out of control. If your building has intrinsic problems in it, if the radiators aren't tilted right, if all the air vents are broken, if the steam traps are broken, we don't fix that. We're not going to install Cozy and magically make these problems disappear. So you really need to have a well-functioning building before we can start to address these big imbalance problems. We try to approach them with this holistic solution. These are the things that we see as wrong in the building. These are the things that you should do, and we have partners that can do this work as well. And then here's the Cozy solution. And so I think, our story is we're going to save you energy. That's almost without question. How much is the question? And then how much is that worth to you versus all these other ancillary benefits we provide, comfort, control, and, building analytics that did not exist before.
Well, particularly when you get especially cold days in New York. So a landlord is skeptical and says, this is going to pay back in 5 years. Why should I do this?
So 5 years is actually a pretty good payback for a building. Our perspective is you shouldn't be looking at this just solely from how long does it pay back, because there are things that we offer that kind of go outside that. So we take over the heating system, right? We're running the building to be as efficient as possible. We're looking for problems in the building. We've told our customers, hey, apartment 4D, the radiators just stopped getting hot, and your tenant's going to start complaining soon. This is why the radiator stopped getting hot. So we can actually pinpoint very small problems in the building, and depending on whether you want to be told if there's small problems like that, and we can identify larger problems. 6th floor, maybe your top floor in your building is your weakest part of your building by far. If you insulated your roof, you'd save a ton of energy. So basically, taking over the heating, providing a holistic oversight to it is of significant value to people. And some people, it's funny, we talked to some people who couldn't care less about the comfort of their tenants. That happens, unfortunately. We speak to people who only care about the comfort of their tenants. And so it really comes down to what matters to the building owner, and it's fortunate that we have value at every angle there. There's this interesting phenomenon in energy efficiency, which is the split incentive. And the split incentive is most things that increase efficiency in buildings do so at the expense of someone or something. And typically it's, I'm going to make you uncomfortable, but we're going to save a ton of energy. Isn't that great? Fortunately, Radiator Labs does not have that problem, because the inefficiency we're carving out for the building is gross, unnecessary waste. So we're making people more comfortable while getting rid of this waste that really is almost unconscionable. I can throw some numbers at you. In New York City alone, $1.2 billion worth of fuel is wasted every year to overheating. So imagine taking like $1.2 billion of any fuel you want, and burning it in the streets. That is literally what's happening, because when our buildings consume heating fuel, they combust and let it out into the air in which you breathe. You've probably seen those big black plumes of smoke come out of the building. That's a boiler. You've probably cleaned off of your windows black soot. That's from boilers. 80% of that is from boilers. It's not from cars.
Why is the city not getting more involved in this? $1.2 billion. Are they looking to subsidize these sorts of things?
Absolutely. It's one of the biggest problems in New York City in terms of energy efficiency, but it's really hard to fix. There's been technology out there for decades that purports to address this. You can fix a building with plumbing. You can do it. It's really hard. One of the guys who is probably the most well-known in this industry is Dan Holihan. He wrote a book called The Lost Art of Steam Heat. And basically the thesis is that, a lot of people in this industry talk about the dead men, which points to the fact that most of the guys who know how these systems work are dead because they built them in 1910. So we have these old buildings. They've been running like this since anyone who owns them has owned them. Do they actually recognize it as a big problem? Probably not. The city does, and one issue is, can they mandate fixes for them? That's kind of a big draconian step. Can they try to incentivize and support the industry? Absolutely.
Are there subsidies right now available?
There are for natural gas. There are not for oil. They're not for district steam, though those are fuels that are more expensive. And right now we're in kind of a fuel price minimum. I'm not going to say ideally, because low fuel prices are great for a lot of reasons, but they're not great in the context of convincing people that efficiency matters. When prices go up, it'll be a much easier sell for an efficiency product. When prices go down, you have to start looking at other stuff.
Do you have any competitors?
In terms of smart radiator covers, no one does what we do, which was a very big surprise when I built the first one in my apartment. I did some research. The competitors are mostly plumbing solutions. And again, there's people who put a lot of effort and a lot of research into these plumbing solutions, and you can make them work. You can. We think that there are some situations where the RadialABS Cozy is not only the best solution, but the only solution. So an example is single pipe steam. The competitor to us is a TRV, a thermostatic radiator valve. I might get in trouble for saying this, but some people call them Danfoss valves because Danfoss is a company that makes this kind of stuff. And when I put that comment on our website, we got a cease and desist from Danfoss. TRVs work for two-pipe steam. You can do it with a really in-depth and careful installation partnered with what's called an orifice plate. Stephen Winters is big on these guys. For single pipe, there's no other solution. So if you want your building to be efficient and to have control, it's Radialabs. If you have two-pipe system, you can potentially increase efficiency with TRVs and orifice plates, but you cannot get control. So if you want to control your temperature and you want high-level insights in your building, we're really the only game in town.
And I was looking at thermostatic radiator valves in research, and they're not that expensive to purchase.
That's right. They're pretty cheap. Although there are some that are the more sophisticated and well-operating ones are a little more expensive. The installation is the most expensive because you need a licensed installer to install them typically. The real Achilles heel of TRVs is that steam is an extremely caustic material. So when steam condenses, it's pure water, and pure water does not stay pure for very long. So it really leaches stuff out and drives a lot of chemical reactions immediately. So the lifetime of TRVs is typically 2 to 4 years. And once they break, they need to be replaced. And there's really no way around that. There are a few advantages we see for the cozy. One of them is maintenance.
The cost of a TRV to purchase is, what, about $50?
That's probably right, yeah.
And installation is how much?
It's probably about $150.
And with the cozy, how long does that last?
So the only moving part in our enclosure is the fan. And we use what I would call the Rolls-Royce of computer fans. So they're designed to be in a hot environment, your computer. They're designed to last forever. I think the mean lifetime to failure is 8 or 10 years, which means that some will fail year one, most will fail after 8 or 10 years, and some will last, the rest of your life. That's the only thing that can break, really.
Do you have a patent?
We do. So that was one of the things I alluded to before, which was surprising, is that there isn't any literature out there on the uniquely enabling things that we're doing here is we're insulating the enclosure, and we're basically manipulating the insulation with a thermostatically controlled fan. And no one's done that before. We have patents that's in process for the US and Europe. It's just that people overlooked the impact you can have by, again, manipulating the thermodynamic equilibrium of steam.
Why do you think no one thought of this idea before?
I think the big issue is that, not issue, but I think that people who are in the know with steam systems are people who know a lot about plumbing, and they know about building systems and how they are now. They're not necessarily people who are thinking about condensation of steam as it relates to the temperature of the room or manipulating that temperature outside of it. They're thinking about valves and things that can affect the flow of steam directly, when there are significant advantages to controlling the secondary effects of those systems.
People were thinking about the trees rather than the forest.
That's right.
And so when did you think, I'm onto something?
When my room became a paradise. Everybody I knew had the problem, right? I talked to my parents who lived in New York City. They thought it was great too. And then I had this is actually a funny conversation with my brother, who was like, who cares? Like, radiators, why would you ever spend time on radiators? Like, no one cares about that.
Your brother who complained about the room?
No, it's actually a brother. I have a second brother. And now he's actually an investor, so I convinced him. I think that the fact that it was a huge problem, in my naivete, I thought that no one had a good solution. That people really care about this, and they put a lot of effort into it. But I think this is another tool in the toolkit that now is the only solution to some, a great solution for others.
So you've estimated the number of radiators in New York. What about radiators all over the country? You have a patent in Europe, too. How many of these radiators are there around the world?
There's about 120 million in the US, and that includes commercial. It's much harder to measure how many commercial radiators there are. The American Housing Survey has so much information on residential stock. There's about 60 million radiators in the US in the residential side. This is all bigger, older cities, mostly in the northeastern United States, although you find it in Colorado. You do find it in San Fran, but they don't have much heating. And then over in Europe, a lot of the countries rebuilt significantly after World War II, and so a lot of those buildings that had steam were destroyed, and after World War II, hot water made a lot of sense. There's a lot of incentives there for hot water. So our system works for hot water, although TRVs work great for hot water. So is our solution better than TRVs? If you look at price, not right now. Eventually, maybe. Do we offer more services? Potentially, but something we'll look into in the future. Very big markets for steam, not in America, are actually Russia and the Ukraine. Not the best markets right now, but maybe one day.
And you participated in an accelerator, MetaProm.
Yeah.
How was that?
It was great. The MetaProm team is a really good team. I like those guys a lot. But they have a very different perspective on the world than I do. I'm a huge nerd. I'm an engineer, right? I'm very technical. They are, and the MetaProm accelerator in particular, is very sales-focused, and it's really nice to be exposed to such a different mindset and very illuminating.
So you brought up sales. How are you going to generate sales?
So we have a sales team now. and we have collateral, we have that third-party verification. We know most people in the city have this problem. We're identifying who are the people we want to approach this year. We're trying to generate buzz and have people come to us.
Are you doing cold calls for landlords or networking? How are you reaching?
It's mostly networking. So some of our current customers are some of the biggest landowners in New York City. Don't want to name names, but you would recognize all of them. And we try to make them happy. Once they're happy, we try to have them introduce us. And that's happening. We also, so I have a COO, Davey Eskel, has been in the industry for a while in New York City and knows a lot of people. And so we do a lot of outreach to people we know, through people we know, et cetera. It's really, it's a small world, real estate in New York City. And that works in favor for some people, and we're one of those people.
Is most of your product sold in New York?
It is entirely in New York right now. We're a small company, we're a young company, we're growing fast, but we do not want to spread ourselves thin. Not only are we not selling outside of New York right now, we're capping the number of installations we're going to do this year. So we're not going to install more than 10,000 units, which sounds like a lot, but actually isn't. It might be 40 buildings. And we're doing that because we could probably sell a lot more than that, but can we actually carry through and do a great job for these people if we're doing 50, 500 buildings? The answer is probably no. We have to build the system to be able to handle that many. So we want to keep it small this year, do a great job for the people we do work with, and then build the process to be able to do a great job for more people next year.
Have you sold out for this year?
We have not sold out yet. So again, it's August. So we still have systems available, although for how long, I don't know.
Talk a little bit about the benefits of starting your company and solving this problem in New York City and what that's meant for you.
New York City is a very interesting place for tons of reasons. So in the entrepreneurial world, there are a few places that people talk about in America. And obviously the archetypal location is Silicon Valley. People talk about Boston, people talk New York. I think I've been around the entrepreneurial environment for now almost 7 years. And it was a very different place 7 years ago, particularly as a clean tech startup, right? It was a dirty word for a while. But things have changed dramatically. Right? When Radiator Labs first started, there were not many incubators out there, and there weren't many accelerators for tech. Well, I wouldn't say tech, hardware companies. And now there are a lot more money available, a lot more investors who are looking at the space, a lot more resources. From Columbia University now has an incubator. The Acre Incubator is great. That's where we really started. Now the Startup New York ecosystem is gaining speed. We're actually working to be eligible for Startup New York, which has great tax incentives. It's a great time, I think, to start a company. I think it's the ecosystem's here in New York and is pretty strong.
Where's the cozy manufactured?
The cozy is manufactured entirely domestically. We get our fans from, America does not make computer fans. But beyond that, we get our sensors from California. We get our circuit boards made in Maine. We get a lot of our injection molding done in Florida. Our metal covers are made in New Jersey. Our fabric covers are made in New York State, upstate. We try to do things in New York State when we can. It's impossible for some things. It's hard for others. Yeah, there's a lot of things you can do in the United States if you want to. There's pluses and minuses. There's very good reason to keep it close because you can call them on the phone and you can get stuff built very quickly and shipped instantaneously, more or less.
Where's everything assembled?
Things are assembled in the factory in New Jersey.
What would your career have been like if your brother didn't overheat in your room?
That's a really good question. I don't know. I feel like I still would be in the entrepreneurial world in some fashion. It certainly wouldn't have anything to do with radiators, which is always surprising to me. I know more about radiators now than I ever imagined I would. And in fact, I was mentioning to you on the way in, it's a blessing and a curse. I share this curse with others because I think it's funny, but I cannot watch any movie or any TV show without immediately noticing every radiator in every scene. And my fiance would probably...
And trying to cover it.
Oh, yeah. Well, maybe not cover it, but she'd be like, hey, radiator. It's a common refrain in my household.
So maybe you can answer this riddle if you know so much about radiators. Why do radiators make that awful clanking sound and sound like they're about to jump off the wall and attack someone?
So there are a few reasons, a few root causes, and they don't have to necessarily overlap with each other. One could be radiators that are not properly pitched. So if the water can't leak back out of a radiator and down the tubes, it can accumulate, and then steam comes in and it bubbles, and it makes a popping noise, and the steam comes in, or it's coming out, and it sucks and gurgles. There are a lot of pressure differentials that are created in these systems when that happens. Sometimes, and this is actually one of the big causes, people think that if their apartment's hot, they can just partially close the valve, and that'll get less heat to them. It actually is pretty big fallacy. If you close your valve partially, it doesn't do anything for the amount of heat that gets to your room, but it does cause that banging noise. And the engineering explanation is that when you have a very small orifice through which steam can get through no problem, it's gas. But the water has a very hard time getting back through. And so when the water, the meniscus in our cups here, water likes to attach to stuff with hydrogen bonding. And when it gets into a very small aperture, it forms basically a water plug. And then you're condensing steam in your radiator, but steam is being supplied in the pipes, and you build up a pressure differential, and that water plug pops, and then you get a bang. And what forms is a Helmholtz resonator. So that pressure change translates into the radiator, back into the pipes, back into the radiator, and that's kind of the twanging sound you're probably familiar with. And there are sometimes just heating, and the pipes cool down and heat up after a while, pipes expand, and that can cause some that snapping noises you're familiar with too.
So don't partially close the valve.
Do not partially close your valve. This is actually one of the things people ask us a lot. Do you guys solve the banging noise? And the answer is maybe. If your problems are intrinsic to the pitch of your radiators, to some weird things that could be going on in your building, no. But if it's because people are partially closing their valves, when we install the Cozy, we open all the valves, and then we more or less entomb the radiator so people can't get to it or have no need to. And if that's the cause, then yes, we do reduce the noise.
How do people find out more about Radiator Labs?
The easiest way is to go online. We are I'd say, problematically communicative team. So we communicate with everybody. People email us, we'll get back to them. We are very happy to go into great amounts of detail into what we're doing. We really like engaging with the community. So if someone wants to learn more, we are happy to speak with them in person, on the phone, whatever they want.
Well, Marshall Cox, thank you for stepping onto the New York Launch Pod and sharing a time with us. I hope that you cover all the radiators across the world.
Absolutely. Thank you so much for having me.
And if you want to learn more about the New York Launch Pod, you can visit nylaunchpod.com or follow us on social media at nylaunchpod.
Thank you for listening to this episode of the New York Launch Pod. For more information, please visit nylaunchpod.com.